Hi everyone. In IR spectroscopy, the electromagnetic radiation used is infrared radiation. Its wavelength ranges from 800 nanometer to 25 micrometer, and this infrared region is categorized into three categories, that is near IR, far IR and mid IR regions. The near IR region will have wavelength from 14,000 to 4,000 centimeter inverse, and the wave number of mid IR region is from 4,000 to 400 centimeter inverse, and the far IR region is from 400 to 10 centimeter inverse. Among them three, the near IR is the less common one, and far IR is mostly used for analyzing inorganic compounds. But whereas for pharmaceutical products, we will be using mid IR, and so the mid IR is also called as the fingerprint region of IR spectrum, and it actually shows peaks for functional groups. And the two key zones in mid IR is group frequency region and fingerprint region. The group frequency region is from 4,000 to 1,500 centimeter inverse. It shows peaks specific for functional groups. Example, C double bond O at 1,700 centimeter inverse. And the fingerprint region is from 1,500 to 400 centimeter inverse. It shows unique peaks for each molecule like a molecular ID. So this group frequency is showing the peaks for specific functional groups. Each and every group will have one absorption at one wave number, and the fingerprint region is like a fingerprint for a molecule. So it will be unique for each and every molecule. It will not change its absorption. And the types of molecular vibrations are categorized here. Why vibrations matter is because the molecules vibrate because bonds act like springs and moving at specific frequencies. So we can all see the molecule consists of different atoms, and the different atoms are linked to each other with the help of bonds, and these bonds are like a spring. So they are actually flexible. So while they are flexible, they will be having electronic energy, rotational energy as well as vibrational energy. And each molecule consists of each atom, and they will be having specific bonds, and these are responsible for the vibrations. So for each molecule the vibrations will be different. So by using that as a basic principle, we are going to employ this IR spectroscopy for analyzing the molecules, the functional groups and their frequency regions. So you can see the various functional groups will have absorption at various ranges. The alkanes will consist of CH stretching, that is they will have absorption at 2,850 to 3,000 centimeter inverse, and the alkenes, that is carbon double bond carbon molecules, will have CH stretch, and they will have absorption at 3020 to 3100 centimeter inverse. So they both are having a stretch. As you can see, the alkyne is also having CH stretch, but the absorption is varied. Their absorption is happening at different wave numbers. So this indicates dependent on the type of compound or groups or bonds that are present within the molecule, its absorption will also vary, and that is why the range is also different. And also in arenes, you can see the absorption is happening at 3030 centimeter inverse. And for alcohol and phenol, both alcohol and phenol will be having hydroxy functional groups, and in this hydroxy functional groups they will exhibit oxygen and hydrogen stretch, and for both they are having absorption in between 3580 to 3650 centimeter inverse. And amines, that is NH2 group, will be having NH stretch for primary amines, and they have absorbance at 3400 to 3500 centimeter inverse. And aldehydes are also having CH stretch from 2690 to 2840. The ketones are having C double bond O stretch, and the absorption is from 1710 to 1720. The carboxylic acids, that is COOH group, is also having OH stretch, that is the hydroxy stretch, and the wavelength is from 2500 to 3300 centimeter inverse. and the ester COO group and the amides CHO group is also having C double bond O stretch, but you can see the wave number range varies for both the compounds, and the nitriles are having C end stretch and they exhibit absorbance at 2240 to 2260 centimeter inverse. So we can see the functional groups are having different types of absorbances in their frequency regions.